Chemistea time. Hello and welcome back to Chemistea time. Today we have a lot more to discuss regarding measurements. In particular, we're going to focus on accuracy, precision, and significant figures in measurements. As we talk about units and measurements, one thing we need to be aware of is the accuracy and precision of our measurements. Accuracy refers to how close a measurement or measurements are to the actual value. Think about a target. Accuracy would refer to how close you can get to the bullseye. The closer a measurement is to the actual value, the more accurate it is. Precision of measurements refers to how close a group of measurements are to each other. The closer together these measurements are, the more precise we say they are. If we think back to our target example, if we hit the target 3 times, we would measure precision by how close the hits are to one another. It is important to point out that even though a group of measurements is precise, this does not necessarily mean they are accurate and vice versa. In STEM, the accuracy of a measurement is determined by the number of significant figures. Since it is often impossible to know perfectly exact values, even with very powerful instruments, we need to estimate at some point in our measurements. So how do we determine what values are significant? Well, there are a few rules we need to follow. First, every non-zero digit is significant. So if we have a mass of 376 grams, this measurement has 3 significant figures. Another example is a volume of 1.275 liters has 4 significant figures. When we start to talk about zeros, things get a little bit more complicated. In a measurement, there are 3 different places we can find zeros. Leading zeros are zeros that come before any non-zero digit in a measurement, such as those in 0.075. The first 2 zeros in this measurement are leading zeros because they come before the first non-zero digit, which is the 7. Leading zeros are never significant, so the value 0.075 would only have 2 significant figures, which are the 7 and the 5. We can also have what are called captive zeros, which are between 2 non-zero digits, such as in 309. Captive zeros are always significant because they are part of the measured value. So in the value of 309, all 3 digits would be significant. The final type of zero we will find in measurements are trailing zeros, which occur after the last non-zero digit. Whether or not these zeros are significant depends whether or not there is a decimal point in a value. If a decimal point is present, such as in the case of 1.500, the trailing zeros are significant because they are showing us that the value is accurate to the thousandth place. So this value would have 4 significant figures. If a decimal is not present, such as in the value of 3,500, trailing zeros are not considered significant because it is assumed that these values are estimated and the measurement is only accurate to the hundredth place. So in this example, only the 3 and 5 are significant figures and the trailing zeros are not. It is important to consider significant figures when performing calculations with measurements. This is because our calculations are only as accurate as our least accurate measurement. This means there are some important rules regarding calculations in significant figures. For calculations that involve multiplication and division, the calculated answer must be rounded to the fewest number of significant figures of the starting values. For example, if we were to multiply by 3.60 by 10.45, the value 3.60 has 3 significant figures, while 10.45 has 4. Therefore, when we perform the calculation, the answer must be rounded to 3 significant figures, so we would round our final answer and it would be 37.6. With addition and subtraction, the rule is a little different. For these calculations, the final answer must be rounded to the fewest number of decimal places present in the starting values. For example, if we were to add 5.725 and 1.6, we would need to round our answer to the 10th place because that is the fewest decimal places in the starting values. So in this case, our answer would be rounded to 7.3. As a reminder, keep in mind to always follow your orders of operations when performing any calculations. Significant figures are extremely important in calculations in science. They allow us to quickly judge how accurate a value is. As such, as we continue our discussions in chemistry, it is important that we always consider them and follow these guidelines in our calculations. Hopefully this discussion has been helpful in understanding the precision and accuracy as well as significance of our measurements. Until next time, have a wonderful day. Thank you.
Chemistea.